Welcome, everyone, to another episode of EEs Talk Tech. As always, I'm Mike Hoffman.
I'm Daniel Bogdanoff, and Erin's been practicing pretty hard. If you don't know Erin from her YouTube channel, you should go check out the YouTube channel. She has a ton of videos over there. She's filling in for Mike today, who is traveling somewhere. I don't even know. He's probably in Europe or something. And we have back with us Kenny Johnson, and Kenny's been at a bunch of R&D sites lately and wants to talk with us a little more about power integrity and all of the fun stuff that goes along with that. So.
Yeah, ready to kind of nerd out on that stuff. I brought this stack of books and everything just so I could try to enhance the appearance of knowing what I'm talking about here.
Our podcast listeners are really feeling it.
Yeah, good. When was the last time you read that much textbook and you weren't in college? Did you even read that much when you were in college?
I've honestly read more textbooks in this job than I have when I was in college.
Yeah, I could probably say the same.
Yeah, kind of the same way, And by the way, Mike, I do like the new look, the swapping the facial hair for the long hair. It's a definite improvement. Yeah. I think we should keep it.
That wig is on point.
Oh yeah.
So I've been on a couple of trips, and I get introduced when I go to these guys. It's like, hey, this is Kenny. He's our power integrity expert. And I'm always like a little shy about that because that kind of expert, it's a relative term. It's in this context, it's like saying I'm the tallest pygmy in the tribe. I know some, right? I know how to make measurements and everything, but not how to design and solve a bunch of problems for people. But most recently, there's this explosion. Everybody with all the smart devices, whether it's IoT kind of stuff or just could even be your phones, your tablets, but all the smart products. And my heart really goes out to these guys. They got a tough challenge because they're trying to design something that has a lot of functionality in a very, very small package and keep it affordable so that the average consumer can buy it, and buy many of them maybe. And that's tough. My perspective comes for us when, we're working on an instrument or something like that, and you charge a fair amount for it, and you've got more degrees of freedom. It can kind of be bigger, and you can have, thick, heavy boards and lots of components, and these guys don't get that. And one thing that I've seen where these guys struggle with is, it sneaks up to bite them, is the relationship between power integrity and the quality of their radios and their ability to pass like EMI, EMC compatibility kind of things. And it's especially mind-boggling to some of these guys that are doing like these little IoT kind of things because, maybe their little application processors just running along at 5 megahertz, nothing's going on, and they don't expect them to have any of these high bandwidth type issues. And a great example was I was working on this one, and it's a platform that they intend to morph into multiple products. And the story kind of goes like this: is that the hardware guy, he's looking at it and he's saying, "Yeah, my supplies all look good and everything," and his software guy was coming over and saying, I'm getting some corrupt data from time to time. I don't think it's my software." And the power supply guy was like, "Well, he's probing his supplies. He's looking at me. He's like, they look solid to me." And they were trying to do some EMC or EMI pre-compliance, because they try to get that wrapped up as best as they can. Or to give you the perspective, because yours might be jaded like mine. Around here we've got our own. Our own screen room. We do our own testing. We've got guys that are, schooled on that stuff, expert on that stuff. But
we have a Doctor Who that does our EMI pre-compliance.
Seriously, we do. Yeah. He's a doctor, and he's smart on this stuff. And so it's something we don't really have to consider the expense or the turnaround time of that. But a lot of these guys, it's they've got to go pay hard-earned cash to some lab to test it, and then you find out you didn't pass. It's like, oh my God, well, why didn't I? And that can really screw up the product cycle.
Set this up a little more. Yeah. So if you're not familiar with EMI or EMC pre-compliance, basically to get a product shipping and sold in the United States or in Europe, you have to pass these specific compliance standards. So in the US, the FCC is setting these standards, and you can't emit outside of certain frequency ranges above a certain power level.
Exactly.
There's another agency in Europe. I don't remember what it is off the top of my head.
Yeah, it's different. They've got class A, B, and C, but basically there's conducted emissions where it's like something is sneaking out through the cable and could, pollute the power in the walls or radiate from the cables. And then there's the radiated emissions, which goes out to about a gigahertz that they're worried about. And that's just so you don't, pollute other products nearby and everything.
And then usually if you're designing a product, you're going to build it and you want to do some basic testing in-house to make sure that it meets those standards to your knowledge before you pay someone else to do the actual compliance testing
Exactly.
of it. So they call it pre-compliance testing because it's kind of your way of checking it in-house. Because if you fail compliance, you have to rework a bunch of stuff and it gets pretty expensive just to go through compliance again, let alone all the rework cost.
Exactly. It's analogous to just, you want to proofread your assignment before you turn it in, right? Because, you get deducted for spelling or whatever else. What's the same thing here is that they want to, you'd like to only have to go through that experience one time. And so what I find that surprises these guys is, like on this one IoT thing that I was looking at, the application processor's only clocking at like 5 megahertz. It's not doing any heavy lifting. It's monitoring, temperatures and humidities and things like that. But the EMC guy, he takes like these near field probes, just like a little loop probe kind of thing, and he's measuring, magnetic fields and electric fields, and he's seeing noise that's out to like 750, 800 megahertz, and they're scratching their head. It's like, where is this coming from, right? That doesn't make any sense. And the power guy, he's like, my power planes look fine and everything. And so I was looking at those two together that like, okay, you're getting some software failures. You're actually getting some corrupt data. You're dropping some bits someplace, and that causes you problems because you waste battery life, right? You got to go resend or somehow correct and all that, or you transmitted corrupt data. So I see that, and I see this EMI thing, and the light bulb went on. There's sections in each one of these books where it's like how power planes are the single biggest source of EMI emissions, just because they're so big and there's so many interconnects and little vias that come through that can actually signals can couple into. So I thought, okay, let's do this. How are you measuring your power supplies? And he's like, oh yeah, I'm just using a one-to-one passive probe. And we're like, well, that's good for a couple things. That one-to-one attenuation ratio, that gives you good signal to noise. So yeah, you can measure those small ripple and noise on your supplies, but I bet there's more energy there than you think. So we threw a power rail probe on there, and typically the way I do it is I always kind of like dial it up to full bandwidth and then look at the FFT and see where things sort of roll off. And we could see energy on these supplies out to about 750 megahertz. And I was like, my gut tells me that there's a direct correlation between the noise on those supplies and that EMI problem that you're having. And as we sat there and we watched it for a while, we were actually able to trigger on noise on the supply. The noise on the supply, it's kind of this alternating like up, down kind of thing. As you write data, you create a load, 0 to a 1, the supply's like, I can't handle this. And it kind of sags down a bit and then springs up. And then when you go from 1 to 0, you release that load and the supply's like, oh crap. And it kind of overshoots and then comes back down. And you get this alternating high-low kind of noise thing going on. And we saw that and we were able to trigger on a spot where all of a sudden it didn't happen in the middle of like when they're writing data. And when we were looking at it with the MSO, there it was, right? You missed some transitions. You actually corrupted the data. The power supply induced jitter in there. So this guy was sitting there thinking, I've got a 5 megahertz clock. I got a 35 megahertz probe. Yeah, I'll just go check this out. Things look fine and dandy. The problem was staring him in the face the whole time and everything. Yeah, he just didn't know any better. He just couldn't see it, right?
The wrong
like,
probe.
Yeah. And so I see that kind of thing happen over and over with these guys, and I can't fault them, right? It's I would have done the same thing if I didn't have the tools available like we've got to start high and then back down to a reasonable level. We just go grab a probe off the shelf.
And that's you get told like grab a 1-to-1 probe for measuring power rails because. That's all you need. You get the better signal to noise ratio, but 6 megahertz bandwidth means you're gonna lose a lot.
Exactly. Or just the thing I think a lot of people, you're working on something like that, and a lot of people have heard, they kind of get the idea that like, most of those like little switchers that are running on like the boards and everything, the little like point of load power supplies and stuff, that's a couple megahertz. And so people have picked up kind of these rules of thumb that I need about 20 megahertz. Right, because that also kind of overlaps closely with like the radiated emissions for like stuff that can come off the board and go out like your USB cable or your power cord or something like that. And I think they kind of draw that line there and go like, okay, yeah, 20 megahertz, that's fine. That's kind of old school too of what we do. And and even if they had higher performance tools, the standard thing I see most people do is they just go grab like their regular 10-to-1 passive probe. Hey, there I got 500 megahertz and everything, but the signal to noise on that is just too much and everything, and they can't see it. So these guys are suffering needlessly. Has been my experience when I talk to them. And there's one thing I wanted to point out along those lines is that my expertise again is in measuring it. But if design is your thing, and this is something that I wanted to mention is that there's a series of YouTube videos that the Keysight's got on designing for power integrity, and one that's super interesting is this thing about optimizing the decoupling caps. And the reason I point that out is because when I go through these references on power integrity here and everything, they all talk about that same thing, that one of the places where you're really going to have a problem with the EMI is improper selection of those decoupling caps or improper placement of those caps. And that's where your problem's going to come. And so going back to like the IoT guy, okay, so I'm trying to design something that's really small, that it's only got a couple of layers, and it's really cheap and everything. So, each time I have to add a capacitor on there, that's money. That's board space. That's a big deal for me and everything.
Well, I think people tend to just kind of slap some bypass capacitors on and hope it solves their problems.
And I've talked to people too that they do that exact same kind of thing, where what they'll do is like, let's say there's for most of us, when we're buying something like an application processor and some sensors or FPGAs or whatever, there's some design guidelines. So let's say you go buy your little voltage regulator from whoever, and they say, okay, put this on the board, put these capacitors near it and everything. And it's in a helpful spirit that this information is coming from the device manufacturers of these voltage regulators.
Sure.
But everybody's system is so different and everything. So people, in some cases, could be putting down a lot of parts that are doing them no good, because the other effects are like the shapes and sizes of your power and ground planes, how far they're spaced, trace links on the board, other things that are adjacent to it. So it really makes a lot of sense if you wanted to turn the knob, I think, and make a difference in the power integrity, for things like that power supply induced jitter, and the EMI thing is really to focus on the decoupling caps. And that's one of those things that I was trying to call attention to in this. So if we can share those links later on and everything, I think somebody will find that very useful, those videos.
Yeah, so if you're working on designing, circuits for power integrity, what are we calling this? Let me see that.
Yeah.
Here.
Sorry.
Yeah, so how to design for power integrity. We'll put the link for that YouTube video series both in the show notes on EESTalkTech.com, EESTalkTech.com, and in the video notes on the Keysight podcast YouTube channel. And there's also another video, the one you talked about, optimizing decoupling capacitors. So we'll put a link for that as well. And if you're watching on YouTube, we'll probably throw a card in or something if we remember when we're editing.
Yeah, exactly. And so, I want to extend it just a little bit farther then, is that, because kind of the theme of this is that we're, if you're working on some of these more, prosaic kind of devices, it's, they're a workhorse kind of thing. They're a consumer item. They're not bleeding fast, but you'd be surprised. The other place where it gets in trouble is that same thing. Even if you're not having an EMI issue, like let's say you've got my package is a nice tight can with nothing's going to radiate out. Well, the same part of the board that's causing the EMI issues can start polluting the radios in these wireless devices, and so. And if you think about it, you're like, okay, so wireless, well, Wi-Fi is like 2.4 gigahertz and everything. Well, okay, so you better be picking up better be looking at energy out there. So that's another one of those ones where the problem could be staring you in the face. It's like, wow, we're having a hard time. Yeah, I'm getting bad link. It's failing the test and everything. Check everything. It all looks solid. Problem's right there in front of you. You've just like put on the blinders and you don't have enough bandwidth to go see the
literally
problem.
put on the blinders.
Yeah.
Interesting.
And so I get people all the time. They're like, well, how much bandwidth should I use? And the answer,
All of it.
Yeah. Well,
You should buy the highest bandwidth you can afford.
just like me with cars, how much horsepower can I get? That's what I want, And and people, they probably do that. But the thing, kind of the advice that I give is, okay, so you've got this scope, maybe it's a multi-gigahertz scope, and you got these power rail probes that are multi-gigahertz and everything. You may or may not need that bandwidth, but start high and get the broad picture, right? See the whole horizon and everything, and then you can dial it down. And so the easy thing that I do is I'll go look at a power rail, and I'll probe it and everything, and then I throw up an FFT, and I just max out the bandwidth, go to 10 on everything, and see where that FFT is starting to roll off and everything. And then I was like, okay, that's about the end of the energy that my circuit is creating. Now I can bandwidth limit to about that edge, and I get a real measurement for the peak-to-peak noise because I'm filtering out unneeded noise because of the excess bandwidth. And then I start looking there. And so that answer may be, oh, look, it's only, a couple hundred megahertz. Or look, it may be a couple gigahertz. And that's why for just to make an excuse here. So, I was sharing with these guys, I had to have some a sports injury fixed on the back of my leg, so I can't take a shower. In between that and
what that's about.
And a new product introduction and everything, it has been busy. So a little disheveled. Haven't had the haircut. Haven't shaved. But one of the things that we did with like that new product then is it's a power rail probe that goes out to 6 gigahertz, because if you start thinking about the Wi-Fi stuff, you got 2.4 and you got 5 gigahertz. And then also when you start thinking about the high-speed data, a lot of these, little mobile products and everything, well, they're using 5 and 10 gigabit USB to kind of unload things. And that right there will start coupling in those reads and writes. Will start polluting those power supplies, and then they start polluting your radios and your EMI issues. And it's all this I don't know, I was going to say incestuous, but there's probably a better term, right? But
Probably.
What else could I use? Well, anyways, they're all tightly coupled, right?
Sure.
And so it's tough. And so how do you break that cycle if you don't know about it and everything? Right. And so I think my message to folks is really, take advantage of the tools that you've got and everything. The science isn't that tough, and the answer's probably staring you in the face and everything. It just, until you know better, you can't do better. And so that's why I wanted to take this time, was to share with these guys that it's like, hey, now maybe you know better, and now you can cut out some of these redesigns and the trips to the EMI site and stuff like that.
Yeah, I know. I don't know how much I'm allowed to talk about other people, but like there's a little like, they call it a wireless oscilloscope. I don't, it's not actually a wireless oscilloscope. It's just much with the aeroscope thing. And they were having some EMI stuff, and that kind of bumped their cost up. And it's like, man, if you're not having problems, fine, you can get away with a 6 megahertz 1-to-1 probe and a low bandwidth scope. But if you're having issues and you can't, find the means to look into higher bandwidths and maybe you rent a piece of gear, you borrow one from, someone down the hall, like, it's fine if it works, but how often does it actually going to work the first time? For me, it never works the first time. So.
Well,
probably the same for most people.
I saw a great setup. This was actually out in Boston, and I think there's a model there that's being used elsewhere, and it's almost like the library kind of thing. And what this was it was not really an incubator, but it was a building that housed a bunch of smaller startups. And as individuals, of course, you can't, where do I find the budget for that, that fancy scope or that fancy spectrum analyzer or whatever, as an individual, you can't, but if you pool your resources.
Right. And
so we're in there kind of talking these guys through this and showing them the best way to use the tools that they've got. And so like you were saying, it's like, rent one, borrow one, whatever. But I also, this is just another thing that I try to throw out as I'm helping people, is that, most of the time the cheaper, affordable, or free tools, like just take like the passive probe that comes on your scope. That's good for qualitative measurements. Is the 5 volts up? Is the clock toggling? Great. But if it's a quantitative measurement, something you're going to check out against a specification, or you're going to take a screenshot of, or you're going to save data files or something like that, something that you're actually a measurement that you're concerned about, then you want to use the real tools. You want to use an active probe. You want to have adequate bandwidth and all that and everything, and then you can make those quantitative measurements. Use those real tools. So some of those other things that you talk about, I think. Awesome as a hobbyist. I've made like little things at home for like my bike and my saltwater fish tank and stuff. EMI, shmemi, I don't care, right? But I got it to working, and there's a bunch of copper tape shielding crap, and a bunch of ferrite beads to try to choke the noise and everything. But that's fine. It's a one-off. But if you're trying to do it, it's just like so many other things in life. I try to educate our boys on this. That I learned it the hard way. Go to the hardware store when you become a homeowner, and it's like, let's see, look, you can get 5 screwdrivers for $1, or this screwdriver for $5. I'll get the 5 for $1. Well, you get what you pay for. So at some point, when you got to do the real work, unfortunately, you got to pay the real money or somehow get the real tools.
This was something that the Adam Savage, the Mythbusters guys says is like, anytime you need a tool, first buy the cheapest one that you can find, and then once that breaks, then go buy the nice one, because you used it enough to break it.
Yeah,
and you're not like coughing up for a super expensive tool that you never.
I like that. Yeah, because there's always that other thing too. If there's the 5 for $1, 1 for $1, or the $5 one, it's like, well, do I really need the top end?
Right.
I don't know, but inevitably when I buy this cheap one, I got to go back and buy another one. Mm-hmm. And so if it's for something that's a real job, invest.
Yeah.
Anyway, so I don't know. Other than that, I'm enjoying summer and everything, and looking forward to taking a shower and shaving here in a couple of days, and getting on with life.
Yeah, awesome. Well, thank you so much for coming out.
Yeah, my pleasure.
Erin, thank you for
of course.
a podcast with Kenny is always great.
Yeah,
it's easy on the host.
Yeah.
Well,
Kenny, honestly, you're part of the inspiration for how this podcast came to be, because we
How
would
is
talk
that?
to you in the hallways, and we basically have the type of conversation we just had for you. And it's just like, man, I got to get this out to people.
Oh, yeah, great. My wife and my kids, we've got a little symbol. So I was, it's kind of a family, sign language thing. And it goes something like this. Was about, 10 or 15 years ago. I can't remember where we were, we're at REI or something like that. We're shopping someplace. And I was making small talk with somebody, and, boy, the guy was a talker. He would just not shut up. And I told my wife, I said, that guy was like a booger on your finger. You just can't get rid of it, right? I was like, he wouldn't shut up. And she's like, welcome to our world. That's you. And so now whenever we're at like some social event, a picnic, a barbecue, or something like that, and I'm like talking to somebody, and my wife thinks it's, they've had enough, she stands behind him and she does like the little and this is how I know. I'm like, oh, okay, I'm being a booger. I'm talking too much. So.
That's really funny. Yeah. If you don't have like my wife and I also have some hand signals that we can use that are subtle that no one else knows.
Mm-hmm.
And
Those are critical.
Super useful. I highly recommend that.
Yeah. Saves the embarrassment. We're also, just for, I don't know why I got there, and you can decide if you want to edit it out or not.
We're keeping it.
Erin and I were talking about this when I came in. Was that my wife's a school teacher, and she works with the gifted and talented kids. And it's amazing. The thing that brought it up was we saw like the Rubik's Cube sitting on her desk and everything. Asked her if she could solve it. And she's like, yeah, sort of. And I watch these kids, little 7-year-olds. They're like, just whipping through this thing. And the genius on some of these kids, it's mind-boggling. And I think when I look at that, there's two thoughts there. One is that the up and coming generations were in good hands. There's some really smart kids there, and their ability to adapt and use the technology and everything is incredible. But I really feel for my wife, because imagine working with a bunch of us when we're little, right? And you're smart, you think you know everything, and it's interesting talking to these kids. I seriously was having a conversation with one of these kids, and he had just learned about dark matter. Now, this is like a 3rd or 4th grader, and he's telling me about dark matter, but in the middle of it, he's also picking his nose. And so it's like, you feel like you're having a conversation with an adult, except you got that going on.
Yeah. I'll tell you what, though, I'll hire someone who knows how to work really hard over someone that I think is like super duper smart.
I think you're right.
Yeah,
I think you're right.
definitely true.
Yeah. Yeah, try to instill that in the people we mentor and, the kids and things like that. We see that in the sports. You get the one guy that's got, incredible talent but a terrible work ethic. I'll take the guy that's shooting 100 free throws after practice every day and that is coachable.
Yeah.
And that's for sure.
Yeah.
Well, okay.
Awesome. So we end every episode with a stupid question.
Oh, cool.
So do you have one or do you want me to start?
You start.
Okay.
Yeah.
So if you had to give someone the worst possible power integrity advice that you could give, what would be the worst advice you would give somebody?
I think back to when I was a kid and we were remodeling our house, and my dad hired an electrician, and my dad was an engineer, like us and everything, right? And so the electrician is going through and he's kind of wiring some stuff, and my dad and the electrician are having an argument about which wires are hot in this based on the circuit breakers and everything. Yeah. And the electrician was like, "It's this one." And my dad's like, "No, it's this one." And the electrician, he was tough enough. He's like, "It's that one." Oh. And that is a test that I'm not willing to do. I would use the multimeter.
So if you're not sure, just poke it.
Yeah,
terrible life advice.
I told the kids, the 9-volt battery, if you're curious, you just touch it to your tongue, right? That's how you find out. So.
But that one doesn't kill you.
Yeah.
The guy didn't flinch. He just grabbed it and just, he was certain in his conclusion that this one is
bold.
live.
Yeah, that is pretty bold.
Okay. Erin, do you have one?
I guess the only thing I can come up with is, what's your favorite probe and why?
Oh, classic Mike question. Well done.
Wow. Let's see.
I'm gonna have to have you scooch back up to the mic before you answer, though.
Yeah, I was deep in thought there. It's gonna be silly because I've designed a lot of them. We use a lot of them and all that and everything. And maybe you'd expect me to say something that I'd worked on or something that we've got a lot of patents on. But my favorite one is we've got this one probe that is for probing 40 kV.
Oh, yeah.
And it's like bright yellow and it looks like a rocket, and it's just intimidating.
It's a piece of equipment.
Yeah. You look at that and you're like, that's serious, and it looks like, I could use it in role playing activities or something else in addition to probing circuits, And that one's my favorite.
That's a good one.
The giant 40K yellow, it's got like a armor piercing tip on it.
It looks like something out of a really bad sci-fi movie.
It does.
That's exactly what it looks like.
It does. Or a different genre, but we're not going there today.
Okay. No, we're not.
No.
So that is all. We should probably end it with that. Thanks for tuning in to EEs Talk Tech. Make sure to subscribe to EEs Talk Tech in your favorite podcast engine. Check us out, Keysight Podcasts on YouTube. So we split it up from the Keysight Labs channel. Also, please rate and review the show. Give us your honest reviews. We'd love to hear feedback for different things you'd like us to talk about. And we will see you next time.